Hello, everyone, and welcome to the session. Thank you all so much for showing the enthusiasm to learn data science. We truly appreciate. Yesterday, we started off by discussing about project management methodology. Within that, we started discussing about a specific project management methodology, which is called as CRISP-DM. CRISP stands for Cross Industry Standard Process for Data Mining. When it comes to your data science projects or artificial intelligence projects or big data projects, people typically use CRISP-DM. When you follow a structured approach, more or less your success is guaranteed. When the success pertaining to your projects is guaranteed. Hence, we would be using CRISP-DM. The first step of CRISP-DM is to understand your business problem. Once you understand your business problem, you need to document two things. One is you document your business objective and the business constraint. You document these two, business objectives and constraints. Once that is done, you proceed further with data collection. And even before that, there are a lot of data types which you should be aware of. And we discussed about continuous data and discrete data. We discussed about continuous data and discrete data. Once you understand about the data types, you proceed further with data collection. There are two data collection mechanisms: primary data collection and secondary data collection. Which one is easier? Secondary data collection mechanism is easier because data is already available. So this is when you already have the data available with you. That's secondary data source, data collected beforehand. And primary data source is data collected at source. Means you go and then and there try to collect the data. Once you have the data at your disposal, you proceed further with the next step of data cleansing, data preparation, exploratory data analysis, and feature engineering. All are interchangeably used. Within this, we are discussing about exploratory data analysis. Within exploratory data analysis, which is also called as, this is also called as descriptive statistics. This is also called as descriptive statistics or descriptive analytics. Within that, yesterday, we started off with first moment business decision, and we discussed about measures of central tendency, mean, median, and mode. And we know for a fact that mean is also called as average, and it gets influenced by outliers. If you have outliers in your data set, it will get impacted. Mean would be a different number altogether. Hence, when you have outliers in your data set, median is a good measure. Median is the middlemost value of a data set, and it does not get influenced by outliers. And when you have categorical data, we use mode. Okay. Today we need to get started with second moment business decision. But even before we proceed with second moment business decision, there is a formula that we need to discuss. And the moment I start speaking about this, a lot of people are like, oh my God, this is back again to haunt me, right? And that is nothing but probability. How many of y'all are scared of probability? Let me ask this question. That would be an interesting question to ask. So the next poll is here. Are you scared of probability concepts? Yes or a no? Hey guys, you can be, pretty vocal. Okay. Let's see how many of y'all say yes, how many of y'all say no. Uh-huh. Do you know what? During my school days, even I was scared of probability. Oh my God, probability. Once again, yeah. But we will ensure, we will ensure that this concept is something that we all like. We all are going to like this. No doubt about that. Okay. So, uh-huh. You love? Okay, wonderful. If you love it, nothing like that. If you don't love it, then you'll start loving it. All right. Very simple, friends. Nothing is alarming here when it comes to probability. Let me explain. Probability is equal to number of interested events divided by number of total events that you have. It is that simple. Now we will try to understand this. One second. Huh? What happened? Okay, fine. So if you flip a coin, if say you're flipping a coin, then you might get a head or a tail. You might get a head or a tail. So the total number of events when you flip a coin are 2. And if someone asks you on what is the probability of getting a head, then head is a single event, one event. It is just one event. So the number of interested events would be 1 because head is 1 divided by total number of events. In total, how many events do you have here? 2 events. You have a head and a tail. So you divide it by 2, 1 by 2. Simple application of this formula is what we are doing here. Probability of tail. The tail that you see here is a single event. So the number of interested events are 1. There is only one single event. Because you're speaking about tail, which is one event, divided by total number of events. In total, how many events do we have? We have 2 events, head and a tail. That's it. This is basic probability. Very simple, very straightforward. Nothing to be scared of. Now let us take another example of rolling a die. Say I roll a die. If you roll a die, you might get, you all are aware of a die basically, right? Or let me quickly show you that here. So this is what I'm speaking about, just rolling a die. Okay, I can also go to images and then show you. This is the die, right? This is a die, right? If you roll a die, you might get a 1 or a 2 or a 3 or a 4 or a 5, right? You can get some number. So let us go back here. Come on. Sorry about that. Yep. So if you roll a die, you might get 1 or 2 or 3 or 4 or 5 or 6. You can get any of these numbers when you roll a die. What is the probability of getting a 1? 1 is a single event, single interested event. 1 divided by, formula says number of total events. What are the total number of events here? 1, 2, 3, 4, 5, 6. So divided by 6. Now question to you all is, what would be probability of getting a 2? What is the probability that I get a 2 when I roll a die? Let me ask a poll question here. So poll question coming your way. Here we go. If you roll a die, it's caps, sorry. If you roll a die, what is the probability that you get a 2? It's, yep. Please answer this. Please answer this, friends. Wonderful. Interesting. A lot of y'all are getting it right, but a few of y'all are getting it wrong also. So I need to explain it in a better manner. Yeah? Okay, let's go back here and let's understand this. We have to apply this formula. We have to just apply this formula. And let's do this. Number of interested events. Here you're interested in a single event called 2. You are interested in a single event called 2. So it will be 1 divided by total number of events. These are the total number of events, 6. Okay. If I say probability of getting a 6, 6 is a single number. So the number of interested events would be one number divided by the total number of events, which are 6. So 1 by 6. This is a probability. Now question to you all. And this is what we do. Every day, we are going to give away the prizes to our participants. People who attend the entire session would be given attendance, and we are going to give you Amazon coupon. And people who have responded to the quiz, yesterday we have posted a quiz, right? We have taken their names and they will also be rewarded. So question to you all, how many people attended yesterday? 2,682, right? 2,682 people have attended. What is the probability that one of you would get this Amazon coupon? What is the probability? So let me pull this question once again, because I don't want any confusion here. In terms of the award, we want everyone to have an equal chance of winning this. So what is the probability of one of you winning an Amazon coupon if, how many people, sorry, I just forgot that, 2,682. If 2,682 people attended the session, will it be 1 by 2,860? I'm sorry, 682, my bad. Or would it be 1 by 2? Yep. Please, can you answer this poll question quickly? Thank God, no one is getting it wrong. 99% of y'all are getting it right. Thank God. Thank you all so much for being attentive, friends. Since you all are attentive, you all know that it's 1 by 2682, the probability of, any one number being chosen. Now what I shall do is, I will go here and I will say random number. generator. When I say random number generator, this is what you get on Google. Directly on Google. I'm not doing anything. Okay, I'll just put the number 2682. People have attended. Out of these numbers, randomly generate some number. So I'll just generate for you. Look at that in that way. It will randomly keep choosing some number here and there. Every number being chosen, probability is 1 by 2682. So let us see who is going to win by just showing up and attending the session. On a count of 3, we would, click on generate. Can we do that? 3, 2, 1, go. Okay, it is 1306. Who is a lucky person? 1309, sorry, 1309. Who is that lucky person? Let's see. 1309, 1309. Okay, wonderful. We have Sukit Sanjeev from Sri Lanka. Sukit, are you there? Sukit Sanjeev, are you there? If we have Sukit Sanjeev, congratulations, friends. Congratulations. Yep, it's 1309. Hopefully it's 1309. Yep. Sukit Sanjeev, congratulations on winning Amazon coupon. You would be receiving Amazon coupon. Congratulations, friend. If you're not there, then not sure, but anyways, you will receive that. Next, people who have given the quiz. Do you know what? If you go and attend the quiz, chances are higher that you get an award because only 238 people have taken the quiz. Everyone can take the quiz. You will get Amazon coupon. So 238 people have responded to the quiz. 238. So let me go to the random number generator. 238. Now let me just test it. I'm testing, okay? Is it working well? Wonderful. Wonderfully. It's wonderfully working well. Okay. Now, all this is just to show you that, such things. The probability of getting any one number is 1 over 238. 1 divided by 238. Okay. So on a count of 3, we will once again click on generate. Let's see who won this. 3, 2, 1, go. It's 114. Let's see who is our lucky friend here. 114. Rohit Rai. Rohit, are you there? Congratulations on winning Amazon coupon. Rohit, are you there? Yeah. Today also, we would be sharing the quiz. For tomorrow's session, there will be a quiz and then you can answer. Congratulations once again. Good. So we are done with the quiz. Now we will enter into learning. Guys, don't be disappointed if your name doesn't get picked up. This is just to motivate you all. On all the 5 days, we will have these awards. Okay. But the core intention is to ensure that I'm not sure. Where did you find 2 different names? Oh, okay. Yep, we will rectify that. Enoch, you will have to take a point. These 2 people are appearing twice. You'll have to take additional care. We will take care. Thank you so much for showing up. Yeah. All right. Thank you so much for participating. Let's now get started from where we have left yesterday. So I will have to go here. We have this 10-hour presentation, day 2. No, I need to go into day 1, module 3, EDA part 2. And this is graphical representation and module 2. All these slides would be shared with you all. Okay, and if you want to access the mind map, you can do that here. And this is a link. I request our team members to put it on the sticky note so that everyone has access to this. Okay, please do that. Today at the end, I'm going to post that. So the mind map is placed on the sticky note. Please go access that. It's a ready reckoner for your interviews, for your, whenever you do a project, to do it in a structured manner, you can just refer to this. Having said that, over to our slides. So let us go to the second moment business decision and let us understand this. Okay. Even before that, what was the first moment business decision? Mean, median, mode. Why is it called as first moment business decision? Because these are the set of initial questions which any management person would ask. These are the set of questions which any management person would ask. The first set of questions. On an average, say, for example, you have HSBC Bank, and say you have HSBC in Singapore, say you have in Indonesia, India, right? So the first question which you as a decision maker or as a senior person in the company would be, on an average, what are the sales across these three locations? On an average, what are the profits across these locations? So on and so forth. Hence, these are called as first moment business decisions. Now we are going to discuss about second moment business decision. Second moment business decision. All right. So we'll first try to understand the intuition, and then we will look at the math, and then we will do it in Python. Say the same example, HSBC. Say you have your branch in Indonesia and Singapore. I'm taking some example. Okay. Say you have the monthly sales details for the last 6 months. So you have 6 months sales, every month sales for the last 6 months. So the second question which your management would ask is, are the sales the same across the locations, or is the sales varying, fluctuating? Are the profits across these locations the same, or are the profits fluctuating? Are the number of people who are working in these countries are the same, or is there any variation? Right, so that will be the second question which any senior management person should ask and would ask. Hence, these measures are called as second moment business decision. Let's understand the intuition. Say you have Indonesia and you have, say, Singapore. And say you have the average sales. Average. On an average, if you have 6 months sales of Indonesia, you can just take an average. That's the average. That is this line. If you have 6 months sales of Singapore, take those 6 months and take an average. You have that. So let's start plotting. Say the first month sales of Indonesia is much higher than your average sales. In the second month, say the sales was down. It was much less than the average sales. Then you have the third month sales, which is above average. Then you have say fourth month. Then you have say fifth month. Then you have say sixth month. So what do you mean by dispersion, variation? Dispersion or variation means how far away, how far away is each month sales in comparison to the average. This distance. How far away is second month sales from the average? This distance. How far away is each month sales from the average? From the average, how far away is each month sales? Is called as dispersion. So if you look at this, seems like there is a lot of dispersion like that. Now let's look at Singapore. In Singapore, say the first month sales was down, less than your average sales. Next month, it was say higher. Third month was here. Fourth month came down. Fifth month was here. Sixth month was somewhere there. Okay. So now once again, what is the definition of dispersion or variation? How far away is each point from the average? How far away is each month sales from the average? How far away is each month sales from the average? This is called as dispersion. If you see here, dispersion seems to be less in Singapore. Just as an example. Now, if HSBC asks you to forecast the forecast sales for next month, then would you be more comfortable forecasting the next month's sales for Singapore, where the variation is less? Or would you be more comfortable forecasting the sales for Indonesia, where the dispersion is more? Where would you be more comfortable, Singapore or Indonesia, in forecasting the next month's sales? Here, let me do a poll and see how many of y'all would get it right. So here is a poll question. Let me reset the poll and ask this question. Which country would you be comfortable in forecasting the next month sales? Let me correct the spellings here. Indonesia or Singapore? Here we go. Please answer to this. Yep. Please, can you all answer? Wonderful. %90 of y'all are getting it right. Absolutely, friends. Absolutely. You would be more comfortable in forecasting the sales where the dispersion is less, variation is less. Less the variation or the dispersion, better will be your predictions or forecasting that you perform. Wonderful. Good. I appreciate this part. Now, do you know what? There is an interesting example. I don't leave, you know, without explaining this example. It's one of my favorites. I'm sure you all are aware of US Food and Drug Administration, FDA. It's world's #1 when it comes to the standards of quality. When it comes to quality standards, US Food and Drug Administration is #1. It's the best. And any food that you consume or any drug that is released in the market, Majorly, it will undergo US FDA approval. That's like quality body for food and drug. And question to you all: how many of you all like eating chocolate? How many of you all like eating chocolate? Let me ask this question. Yeah, this you can just post in the chat window. Come on, friends, let's be interactive. Come on. How many of you like eating chocolate? Yep, I'm waiting for your responses in the chat. Okay. A few of you all hate, but a lot of you all like it, right? You all like chocolate. You love. Wow, wow, wonderful. Majority of you all like it. So, just to spoil your mood a bit, let me ask this question. How many insect fragments are permitted in 100 grams of chocolate? How many insect fragments? When I say insect fragments, I'm speaking of about head of a housefly, leg of an insect, in that way. I mean, they won't purposefully put that. Okay, don't get me wrong. No one would purposefully insert an insect into chocolate. But chocolate is so sweet that flies usually, how much ever precaution you take, flies fly its way, when finds its way into the manufacturing process. And accidentally, if a fly falls into the chocolate, then you cannot even identify that. They are very small. Yep. So, do you know what? I know you all won't believe me, won't trust me. Yeah, until and unless I prove it with statistics. So what I shall do now is I'll go here. Yeah, a few of y'all are getting it right. Wonderful. If you just say US FDA and insects, let me show you this. Look at that. In chocolate, here it is chocolate. So in 100 grams of chocolate, if you have more than 60 insect fragments, it would be rejected. If you have less than 60 insect fragments, hey, you can consume it. It won't harm you. Yeah. So this concept gets applied there, wherein you have 60 here, you have 0. If any chocolate sample has more than 60, then it is rejected. It should not be released in the market. If you have under 60 insect fragments, safely consume. Doesn't matter. Protein. Yeah. Excess protein. Okay. So, there is another interesting example. Uh, there is something called as pulpy orange. Pulpy orange. This is citrus juice. When it's a citrus juice basically, okay, pulpy orange. You'll have a lot of pulps of orange, right? When you consume orange fruit, you'll have pulps. And when you drink pulpy orange, it is going to taste very natural. You'll feel this natural pulps when you consume this pulpy orange. But question to you all: how many fly eggs are permitted in 250 ml of canned citrus juice? My friends keep saying me that, do you know what? If you consume canned citrus juice, it's much healthy. I mean, it doesn't get contaminated. Oh, come on, give me a break. So just answer this. How many fly eggs are permitted in 250 ml of canned citrus juice? Any thoughts? Anyone? Let me look at the number. Let me look at the count. Yeah, now no one can claim you are vegetarians. Would you? Yeah. All right. So let me answer this basically. Um, do you see here the second option here? The canned citrus juice. Five or more Drosophila or fly eggs are permitted in 250 ml of canned citrus juice. That means if you have more than five, it is rejected. But if it is less than five, you can consume it. It is safe. No worries. So again, once again, this logic continues that you have five, zero. If any of your canned citrus juice has more than five fly eggs, it is rejected. As part of quality inspection, they do that. All right. Now, what are these measures of dispersion? There are three, my dear friends. There are three measures of dispersion: variance, standard deviation, and range. Okay, we will discuss about these three. These three. So let me go here. Exploratory data analysis. You have a second moment business decision. Primary, we already discussed mean, median, and mode. Second moment business decision, which is also called as measures of dispersion, has three: variance, standard deviation, and range. Okay, so I just got a message that a lot of people are asking for the YouTube channel and the recorded videos. So once again, oh, not this. So where do we have that, Enoch? Okay. So guys, please subscribe to the YouTube channel, because otherwise you will keep asking us on where are the recorded videos of the previous sessions. I request you all to click on the link that I've shared. Attendance link towards the end. Towards the end. We still have good 1 hour, 20 minutes of session left. Towards the end, we will post that. Okay. So you have the mind map, number one. You also have the YouTube link. Facebook, we will let you know today towards the end. Presentation slides we will share with you on the, we will let you know how we will share on the last day. Okay, on the last day. Here we go. Right, that's the YouTube channel, and then you also have the mind map. Right, so enjoy the sessions. Please subscribe. Please subscribe. We have a lot of people. I just request you to click on subscribe. All the future recorded videos would be provided to you on that. Unfortunately, we want to track the attendance, sorry, not attendance, your answers also, Sandhya. So it'll be difficult for our people to manage 2000 odd, responses. Hence, you can create a Facebook account. It's pretty simple, right? Okay, thank you all. Let's proceed further now. Where is the, do I need to open this now? Yeah, here it is. So let me explain here. Let us understand variance, standard deviation, and range. Say we have weights of people measured in kgs. First person, say, weighs 30 kgs. Second person weighs 40 kgs. And the third person weighs 50 kgs. What did we discuss about dispersion? How far away is each value? How far away is each value from the average? How far away is each value from the average? And then you square it. Why do we square? We'll understand all these numbers, and you divide it by n. So there are three numbers. So it would be summation of I equal to 1 until 3 xi minus mu whole square divided by 3, because n is 3. You have three numbers. When I substitute I equal to 1, you get x1 minus mu whole square plus x. If I substitute I equal to 2, you get x2 minus mu whole square plus, if I substitute I equal to 3, x3 minus mu whole square. Assuming that we have only 3 people on the planet, Adam, Eve, and their kid. Assume for now, right? Assume that this is a population. So, so you need to know what is this mu. Mu is nothing but mean. This is nothing but mean. So how do we calculate mean? We already know that. So let's calculate the mean. Mean or average is nothing but, you say average of these 3 numbers, you get 40, units is kgs. Now how do you calculate it? You say 30 minus 40 whole square. So rather than taking this route, I'm going to solve it here. Okay. So let me calculate xi minus mu first. So xi minus mu is minus 10 kgs. x2 minus mu. Each value, how far away is each value from the average? Remember, how far away is each value from this average? So I say x3 minus mu is so much. Now, if you add all these 3 numbers, what do you get? Minus 10 plus 0 plus 10, what do you get? You get 0. You get 0 kgs. Does that mean there is no variation? Oh no, there is clear variation. 30, 40, 50, there is very clear variation in the data. Then why is it 0? So statisticians thought that there is something going wrong here in a big way. So statisticians thought, we need to fix this. And a brilliant person in the room says this, that let's do one thing. If we square this, if we take xi minus mu whole square, then this problem gets fixed. Wonderful. So they then started squaring. Who? Statisticians and mathematicians. And then your units also get squared. If you say 0 square, you'll get 0 and units square. Again, if you take 10 and if you square that, you get 100 kgs square. Now, that is exactly what we have in the formula. Why did we square? Just to ensure that the units do not get, cancelled out. That's the only reason why we have it in this way. Okay. Now what we shall do is, I'm going to calculate variance. What is variance? Variance is nothing but add all these 3 numbers. When you add all these 3 numbers, what do you get? You get 200. 100 plus 0 plus this, 200. Divided by, see, that's what I'm doing here. Xi minus mu whole square x2. I'm adding all these 3 numbers and dividing it by the total count, which is 3. There we go. Kgs square. So it is 66.6 kg square. And then you have standard deviation. Why standard deviation? Let me hold on to that thought. If people ask you on what is the variation of the weights of your employees, if you say 66 kg square, oh my God, kg square? Are you mad? If I ask you on what is the variation among the salaries of your employees, if you say it is $1,000 square, how do I interpret that? Units are getting squared. And do you know what? 30, 40, and 50 are the weights. But how can you say that the variation among the weights is 66 kg square? Then statisticians again thought, we need to fix this. And again, brilliant person in the room told, hey, my dear statisticians, you squared, right? That's why this is a problem. Now do one thing, take a square root take a square root of these. Square root. The moment you take a square root, this problem of units getting squared would get cancelled, and that is called as standard deviation. Simple. So what is standard deviation? It is nothing but square root of variance. None. So you take the square root of this. The moment you take the square root, you get 8. And when you take a square root of units, you get back your original units. Wonderful. And there is another measure, but even before that, let me go back here and then do a quick recap. So, what is the disadvantage of variance? Disadvantage of variance is that your units get squared. And how do you fix that? You fix this issue by taking a square root of variance. Yet you take a square root of variance and that issue gets fixed. Simple. Variance, standard deviation. Now, let me explain about range. But before I explain about range, or let me explain about range. Range is nothing but minimum value or maximum value minus minimum value. What is the maximum value of your data set here? It is 50. That's the maximum value. Minus. What is the minimum value in this? Minimum value is 30. So that is going to be your range. You can use any of these measures to measure your dispersion. You can use any of those three. There is no hard and fast rule on what you use. People usually for interpretation purpose use standard deviation. Otherwise, you can use variance, range, etc. That's second moment business decision. Okay. Let me go back here. All good? All good. So I don't see anything alarming here. So let's go to Python. Where is this Python? Python. Yep. Spider. Here you are. So let's calculate, variance, standard deviation, and range. I did not close this from yesterday's session because I wanted you guys to learn that. Anyways, so let me calculate here. The same thing, we are working on the same education data set. These data sets, the Python code would be made available to you on the last day of the session. How we are going to give access to you all to that is something that we are going to notify you. All right. So education dot work experience dot variance. What does that mean? Let me open this. If you want to calculate variance of a column called work experience, and since this work experience is in this data set called education, you say education dot work experience dot variance. Education dot work experience dot variance would give you variance, right? That is what is given here. That is how you refer to a column. And then dot var is a shortcut for variance. And you know that when you place your mouse cursor anywhere on the line and click on this run, it would give you the result. What if I want to calculate the standard deviation? What do you do? Same. Go to education dataset, go to work experience, and say .std, standard deviation, and just click on run. There we go. We have the standard deviation. For range, as you know, it is maximum value minus minimum value You take the maximum value of this education. Within education, I'm referring to this column work experience. If I click on that, look at that. This is the maximum value. You can just highlight a portion of your code and then execute that, run that. So I'm selecting only the minimum value. And then if I click on run, it gives me the minimum value. When you subtract the maximum value minus minimum value, you get the range. There we go. Range. So the range, I'm storing this. I'm subtracting the maximum value from the minimum value, and then we are storing that in an object called range. And when I say, hey, what is in that range? Can you display? It says 270. Wonderful. We understood measures of central tendency or first moment business decision. We calculated mean, median, mode. There is another way of calculating mode, not needed. And then we have also discussed about measures of dispersion, second moment business decision. And then we calculated variance, standard deviation, and range. Please post in the chat window one quick thing. What if I want to calculate variance? What if I want to calculate variance for GMAT score? What if I want to calculate variance for GMAT score? What is the function in Python? What is the code in Python? Can you please reply on the chat window? If I want to calculate variance of GMAT, what should you type in Python? Come on, you all can do it. It's there on the screen also. We all need to become perfect. Practice makes you perfect. Yep, quickly respond. Let me see the chat window. Wonderful. Wonderful. I truly appreciate your learning here. So we are learning the concepts. We are learning the math behind the scenes. And we are learning the Python code as well. And we are going to make best use of the 10 hours. Good. Thank you all, guys. Thank you all for responding. var, guys. Don't forget it's .var. Only .var. So if I want to calculate, you just type .gmat.var. Hey, this hash is a comment, guys. It's a comment. It's like instead of making a note on your book or a paper, you can actually make a note here. But you have to type it after hash. Even without that, hash is just a comment. Even if you don't have, that's okay, but this is a best practice to mention on what this function, this line of code is doing for you. For GMAT, if you want, I'm saying go to education.gmat.var. If I run that, you get the variance. And if you want the standard deviation, you say education.gmat.standard deviation. When you click on run, you see that. And if you want the range, simple. You can just say maximum value of education dot GMAT score minus minimum value of education dot GMAT. Minimum value minus maximum value, that will give you the range directly in the output. You're not storing this in any object. You can store, or you might say, hey, I don't want to store that. I want to directly display the results in the console. This is called as console. Let me quickly write that. This is called as console. And this is called as script window, wherein you write your script or you write your code. Script window. You can write the code here and save it. And for future purpose, you can just save that. And then when you execute that, you see the results in the console here. I can explain about a few projects which are exclusively run on social media analytics. That's called as social media analytics. We have on our company website also something called as social media analytics. It's all about extracting the sentiments from Twitter, extracting the data. You perform risk sensing for organizations. Is there anyone writing negatively about your organization on Facebook? We need to know that because certain segment of people prefer Facebook for these kind of casual talks. Political party representatives are people writing negatively about the political representative in their location, or are they writing positively about that person? What issues do people in that community have? They obviously would not post such things on LinkedIn, right? They would resort to Facebook to express their dissatisfaction. You, as a data scientist, have to extract the data from Facebook, and then if some issue is blowing out of proportion, right? Someone is, getting just disgusted, a community, they all want to go on a strike. How can you be notified of that so as to maintain the law and order in that locality? Maybe you can go up front, talk to the people, and try to solve that problem. These kind of things are happening in a big way. So you need to have accounts. Think about this as an opportunity for you all to create the account. Yep, please create the Facebook account, and then it's very easy, very simple. Oh, yeah, it's legal. It's legal. If, say, someone is trying to, you know, speak negatively about a company, wouldn't you want to know that? But you cannot extract it without Facebook approval. You have to prove it to Facebook that, you know what, we want to extract this content, this data for this purpose. That's very important. Okay, how to create a Facebook account? It's pretty simple. It's given there. So just create. It's like creating your Gmail account. Yeah, Kavya, you have to create a Facebook account. Please do that. And then just follow the process. There are two steps in the process. Step one, you click on the group here on the sticky note. Everyone, if you are on the chat window, there is something called as a sticky note on the top. I'm hovering my mouse on that. You'll have to click on that. You'll have to join the group. We will give you permission. After we give you the permission, you have to click on the next link. It's a private group. We don't allow anyone and everyone to be there on the group. We only want serious learners to be there on the group. All right, we will get back to this again and then discuss further, but let us proceed further. All right, again, a quick recap. First, you need to understand the business problem, then collect the data, then perform exploratory data analysis. We just completed the first moment business decision and the second moment business decision. Now, we are going to look at graphical representation. We are going to discuss about three key plots as part of this. There we go. What happened? Sorry, yeah. So we are going to discuss about bar plot, histogram, and box plot. This is a bar plot. And this is a histogram. First, let us do these two things in Python, and then we will understand more. Okay. Plots. Even before I go to plots, as I've told you, there are certain packages or libraries within Python. One should be aware of all of these to learn Python well. Number one, you should be aware of a library called NumPy. NumPy is used to perform numerical calculations. It's used to perform numerical calculations. Second, you have another library called as SciPy. SciPy is used for scientific calculations. These are all called as libraries, my dear friend. Libraries. Third, we have another package called as Pandas. Pandas is used for data manipulation. Data manipulation means to load your data sets into the tool, into Python, to add different columns, to merge different tables, so on and so forth. That's data manipulation. Manipulation is not a wrong word. I mean, people take it negatively, but no. Four, you have something called as scikit-learn or sklearn. This is a library within Python which is used for machine learning algorithms. Number five, you have something called as matplotlib, which is used for data visualization. And then you have a lot of other things. You have something called a stats model. We're going to discuss about this also, which has statistical analysis capabilities. And there are other tools also for deep learning purpose. We have TensorFlow, Keras, PyTorch, TensorFlow, Keras, PyTorch. These are fast picking up. These are used for deep learning, for running deep learning algorithms. Okay, all that aside, we will get there. Libraries are collection of code, functions, or programs which someone else has written in the past. Someone else has written in the past, and we try to reuse that. That's the definition of library. Like in a typical library, you have books. It's a collection of books. Here, it is collection of code or functions which someone else has written in the past. Okay, so I'll erase this and back to this. Matplotlib. Within Matplotlib, which is used for data visualization, there is something called as PyPlot, Python plot. You are importing that as PLT. If you don't import, if you don't have this part, assume, then if you have to run a bar plot, you have to give the complete name. You have to say matplotlib dot pyplot dot bar plot. Oh my God, this is pretty lengthy. So this part, I'm giving it a shortcut called as PLT. So that I say PLT dot bar. It's easier, simpler. So this is an abbreviated name for this. Same is the case with NumPy. import numpy as NP because this is an abbreviated format of numpy. Good one. So let me import these two. And let me say I want to do a bar plot. If you want to do a bar plot, it's plt.bar. You want a bar plot for what? For say GMAT score. For GMAT. How do you refer to GMAT? You say education.gmat. And each and every GMAT score that you see, each and every GMAT value that you see is going to be represented as a height of a bar. This height of a bar would be represented using these values. And on x-axis, what do you want? On x-axis, you're saying that you want to arrange, you want a range of numbers from 1 to 774. Why? Because you have 773 rows. So each row would be a bar. Each row would be a bar. Each row would be a bar. So how many values do you have? 1 until 774. And what does this 1 mean? This 1 means you want to increase it from 1 to 774. You want to take numbers in an increment of 1. That means 1 increment of 1 is 2. 2 increase it by 1, 3. 3 increase it by 1, 4. That's the meaning of this. So you start from here, you end with this number, and this is the increments in increment of 1. And then you're saying from NumPy, within NumPy, there is this function called a range of numbers. And this is what you're saying. Okay. So let me run this. Ah, there we go, bar plot. We have the bar plots. From 0 to 774, you have the bar plots in an increment of 1. Wonderful. But by looking at the bar plot, we cannot comment much. We cannot draw any meaningful insight by looking at this bar plot. Okay, by looking at the bar plot of the GMAT scores of 773 students, you cannot make out any meaningful sense. Hence, people came up with another plot, which is called as histogram. So you're doing the same thing. You're taking education, GMAT from that, and then you're doing a histogram. Let's do that. Histogram. So PLT from this matplotlib.hist would give you a histogram. Histogram is also called as frequency plot. Also called as frequency plot. We run this. Wow, look at that. So by looking at this, you can draw some meaningful insights that, you know, in this particular college, there's a college data, right? This is from a specific B school. Students get admitted in the B school. And what is the GMAT scores that they are getting? That is what is plotted. Now here, if you observe, the highest GMAT score that one can get is 800. That's the maximum. And majority of y'all, if you see here, majority of y'all, of these students have a GMAT score between 710 to maybe 725. And if you look at the bar here, You also have the count on how many students have that score. In excess of 250 students have that score. So the moment you look at that, you know for a fact that majority of the students have a GMAT score from maybe 700 to 725 or 710 to 725. That's one key insight that you could draw. Another key insight is there are very less number of students who have the GMAT score, maybe less than 675. Less number of students, very less number of students. And very less number of students who have a GMAT score greater than 750 are joining this B school from whichever business school this data is. Very less number of students are joining. Majority of them who are joining have a GMAT score in this range, and this is your mean or median or mode. The central tendency is this part. Okay, so this is how you draw the histogram. So let me go back and show you here that we have graphical representation, univariate plot. Univariate means single variable. So what am I doing here? If you look at this Python, I am taking a single column and I'm doing a bar plot for that single column. I'm doing a histogram for single column GMAT. Since I'm drawing a bar plot or a histogram for a single column, it is called as univariate. Univariate means single. So we have histogram. Next, we have discussed this part. Let me go to this. Okay. And we discussed that if you have numbers in this way 1, 2, 3, 4, and 700, what is the 700 called as? Anyone? What is this extreme number 700 called as? Come on, friends. Can you please resort to the chat window and respond? What is that called as? Quickly. What is the 700 called as? Quickly, can you all respond? Absolutely wonderful, friends. Wonderful. I truly appreciate. It is called as an outlier. Exactly. It is called as an outlier. Since there are only 5 numbers, you can very easily identify this as an outlier. But what if there are, say, 30 million records? What if this is a huge data set with 30 million observations or records? How would you identify outlier if you have such a large data set? How would you do that? We need some good way of representing or identifying the outliers in such a large data set. And the visualization tool, or the technique rather, which we are going to use to identify outliers is called as box plot. It is called as box plot. Let's spend some time on box plot now. When you have your data, you can represent 100% of your data using a box plot. The notation that you see here, this is called as lower extreme or minimum value. And here you have lower quartile or the first quartile or Q1. Q1 or lower quartile or first quartile. Then you have your upper quartile, which is called as third quartile or Q3. And then you have your median. Median is also called as second quartile or Q2. Second quartile or median or Q2, and then you have the first quartile minimum. And then you have this extreme value or the maximum value. You have the upper extreme or the maximum value. And here, what do you mean by first quartile? 1 quarter. 1 quarter means from the minimum to the first quarter, you will have 25% of data. And then if you take 3 quarters, what percentage of data would you have here? What do you mean by 3 quarters? Let me quickly ask a poll question. Quickly, let me go to the poll and let me ask this question on from minimum to Q3, what percentage of data resides on box plot? Is it 25% or is it 75%? There you go. Please, can you answer to this, everyone? I request everyone to kindly respond to this. Wonderful. Guys, you are awesome. You're responding it in a very good manner. Greater than 90% means it's extremely good, right? So 3 quarters means you have 1 quarter here and 2 quarters here. So 3 quarters would mean 75% of the data. If from the minimum value to the third quartile, if you have 75% of data, and if from the minimum value to the first quartile, if you have 25% of data, then my question to you all is, what percentage of data would lie here in this region? What percentage of data would lie here? It will be 50%. Absolutely. If from here to here, if you have 75% of the data, and here if you have 25%, the middle portion will have 50% of data, and this middle 50% of data is given using Q3 minus Q1. 75% minus 25%, you get 50%. And then you have the upper extreme, which also has another 25% of data. Now, point to be noted. If you have any value which falls below this minimum value or above this maximum value, these will be called as outliers. Do you have an outlier here? Yes, we have an outlier because it's falling below this. Wonderful. So let me go back to Python and let's do this. Box plot. Simple. You just need to say, go to PLT. PLT is matplotlib. From that, you're picking up pyplot, PLT. Dot box plot. And you want to do a box plot for GMAT score. You have education.gmat. When you do a box plot, when you run that, there we go. Do we have outliers in this box plot? Yes or a no? Poll question quickly. Let me ask this question and then I would go back and show you that. Do we have outliers in the box plot? Yes or a no? Let me publish. I forgot. Preview publish. Yep. Please answer that. And here is a box plot. By looking at this plot, I want you all to comment on whether we have outliers or not. Do we have outliers in this? Do you see that? If yes, then please respond to the poll. If no, also you will have to respond. Okay, wonderful. 94% of y'all are saying yes. appreciate. So you're right. There are outliers in this data set, and these are the outliers. These are called as outliers. Wonderful. So you have outliers, so you need to analyze the outliers and decide on what to do with that outlier. Okay. As part of full-blown training, which is for 250 hours, we get into the depth of each and everything, how to calculate the outliers, what is a formula, so on and so forth. But given that we have 10 hours and then yesterday 2 hours we exhausted, today also we are almost exhausting the 2 hours. So we'll be a little concise, right? So if I do this, plot dot box plot of education dot, mm, let me pick work experience this time. Work experience. If I run this, I'll get another box plot. Do we have outliers in this data set? Sure, yes, we have. What did I say? If you have values which are above this or below this, then you would call those as outliers. So do you have outliers here? Sure, you have. Okay, so you have outliers. Okay, there are many other plots, guys. So, friends, but you know our limitations, right? So these are univariate plots. Why are these called as univariate? Because when you look at the box plot, we have taken a single variable, GMAT, a single variable called work experience, and we have resolved that. And when you did a histogram, we looked at a single variable called GMAT. When you do it for a single column, a single variable, it is called as univariate analysis. But then we also have bivariate analysis. What do you mean by bivariate? I want answers from you on what we mean by bivariate. Question coming your way. I request you all to answer. Bivariate includes how many variables? Uh, more than two or exactly two? Let's see. Yep. Please, can you answer this? What do you mean by bivariate plot? Does bivariate mean exactly two or more than two? We are struggling to reach that 80%. Yeah, if you see this, but great, greater than 80 to 80% is amazing. So, absolutely. Bivariate means exactly two. Univariate means single. If you do univariate analysis means you are doing analysis on a single variable. Bivariate means you're doing analysis on two variables. Multivariate means you perform analysis on multiple variables. So if you have greater than two variables, and if you analyze that, it is called as multivariate analysis. Multivariate analysis. Of course, multivariate analysis, etc., would be part of our uh, full-blown training. For this free session, we will discuss about bivariate analysis, in which we would discuss about scatter plot. So let me open that. Okay, here we go. Is it module 3? No, I think it's to linear regression. Tomorrow we will be building a machine learning algorithm. Tomorrow we would be building our first machine learning algorithm called linear regression. Okay, so do attend that. All right. Even before we proceed further with scatter plot, I need to help you understand about an important equation called y is equal to f of x. Y is called as output variable and x is called as input variable. For example, say you want to measure the weight gained by a person during the lockdown. Lockdown going on everywhere, people are gaining weight. So how much weight did you gain? Right? Weight gained depends on what? It depends on an input called as calories consumed. The amount of food that you take in is going to decide the weight gain. 80% of times, this is the story. Now, this is one scenario wherein you have a single input variable and you have a single output variable. Sometimes there might be multiple input variables also. For example, you might ask me this, hey, would I get a job? Right? Would I get a job if I learn data science, if I enroll for the data science training? Okay, so your question is whether you're going to get a job or not. That's the output that you want to look at. What does it depend on? Many inputs. It depends on what is your attendance. Are you attending all the classes or not? Number one. Plus, it depends on another. So it depends on one input. Another input would be assignments. How many assignments did you submit? It depends on that. Third, it depends on whether you are working on the live projects or not. You need to practice. Without practice, it won't help. Plus, wherever you enroll for the training, are they giving you support on resume preparation or not? Resume preparation. Plus, what kind of international certificates you would get? International certifications. It depends on all these aspects on whether you're going to get a job or not, whether you're going to become a data scientist or not, or AI expert, or maybe a data analyst, or maybe a business analyst, or there are many names, data modeler. And there are many other names which exist. Okay, anyways. So output that you want to achieve might either depend on a single input or it might depend on multiple inputs. Having said this, let me now help you understand about scatter plot. Let me go here and then explain about the scatter plot. Scatter plot is a bivariate plot. What do you mean by bivariate? Bivariate means you'll have two variables. You'll have two variables by x-axis, y-axis. I'll give you a simple representation. Okay. Say you want to look at the amount of time spent in a shopping mall and money spent. Say you have gone to a shopping mall along with your girlfriend and you're say tracking this 1 hour, 2 hours, 3 hours, 4, 5, 6 in this way. And the money spent is $50, $100, $150, $200, $250, so on and so forth. Usually when you go to a shopping mall with your girlfriend, what do? You try to, try to show that you are a hero, yeah. And then for 1 hour, say you spend $50. For 2 hours, say you spend $100. Third hour, you're like a little nervous. Should I spend 1 more hour? And then you'll say, okay, let me spend and see. $150. If you spend 4 hours, 200, 5 hours, 250 hours. If you spend another hour, you'll go bankrupt. Yeah. If you see this kind of a correlation between these two variables, that is, as and how the time spent increases, if the amount spent also increases, then this is called as what? Positive correlation. Positive correlation. Positive correlation means as and how the time spent increases, the amount spent also increases. That means there is a positive correlation. Okay. Then let us take an example of negative correlation also. Hey guys, this is on a jovial note. Okay. Then say you have, let me minimize this also. Yeah. Say on x-axis you have years of experience. Years of experience. And on y-axis, say you have productivity. On how much productive you are. Okay. And whatever be the productivity, and then you have the years of experience, 1 year, 2 years, 3 years, 5 years, 10 years, 15 years. You have all that experience level. And here, productivity, however you measure it, say productivity is high, medium, low. You measure using some number, but I'm just giving it in a categorical manner here. When you are a fresher, you're new to the industry, what do? You want to prove that you're the best. So your productivity would be high, very high. After a few years, you become a team leader on a jovial note, okay? On a jovial note only. Okay. When you become a team leader, what happens? Slowly your productivity decreases. Why does it decrease? Because maybe you have offloaded your entire work to your team members and you are a little relaxed. So your productivity, say, comes down. The moment you gain 10 years experience, say you become a manager, your productivity further decreases because now you're offloading the work to your team leaders, who are in turn offloading the work to your analysts who just joined the organization. If your experience increases to 15 years, what happens? You become a vice president, you're given a separate cabin to sit, a separate room for you, wherein you can sit and watch Netflix movies, a lot of videos on YouTube. So your productivity further drops. Assume, I'm just giving a jovial explanation here. So if you see an explanation or if you see a correlation like this, that is, as and how your years of experience increase, if your productivity decreases, then what kind of correlation is this called as? Poll question coming your way. Please answer. Poll question coming your way. Please answer this. So in this case, let me type it. As and how or if productivity decreases with the increase in the years of experience, then what kind of correlation is this called as? Okay, come on. There is a spelling mistake here. Let me rectify that. This is called as positive correlation or negative correlation. What is this called as? There you go. Please answer. Good, good. Greater than 95% of people are getting it right. Amazing. Amazing. This is in fact called as negative correlation. Why? It is coming down, so it is negative. One is increasing, another is decreasing, so it's negative correlation. If one is increasing and another is also increasing, then it's called as positive correlation. Positive correlation, negative correlation. Scatter plot. Now this scatter plot is called as bivariate because in these plots, if you observe, we are looking at two variables, right? We are looking at time spent and money spent, two variables. So bivariate. Here you're looking at years of experience and productivity. Hence it is bivariate, two variables. Great, great, great. Okay. Scatter plot will help you understand the direction. So if you look at this is positive correlation, meaning as in how one variable increases along this direction, another variable is also increasing. This is positive correlation. If you observe here, as in how you increase along this direction, this is also increasing. So this is also positive. Here there is no correlation. There's no correlation. Here there is negative correlation. As in how you go along this direction, it's decreasing. Negative correlation. Here also, as in how you go along this direction, you're decreasing. Negative correlation. Okay, then you have positive and negative. Number one, scatter plot will help you understand the direction of the relationship on whether the relationship is positive or negative. Second, it will also help you understand the strength of the correlation on whether the strength is strong or moderate or weak. Whether the strength is strong or moderate or weak. So here, if I draw a line, if you see these points are very close to the line. Hence you call this as strong positive correlation. Strength is strong. Here if you observe, there is a slight dispersion. There is a slight dispersion like that. When you have a dispersion like that, it's called as moderate correlation. If you look at this, the points are very closely cluttered. So you call this a strong negative correlation. Here, since the data points are slightly scattered, there is slight dispersion. It's called as moderate correlation. If the points are further scattered, they're far away like that, then you call it as weak correlation. So scatter plot will help you understand the direction. It will also help you understand the strength. Third thing is, it will also help you understand, I'll put it here. The third thing is, it will also help you understand whether the relationship is linear or non-linear. Linear means a straight line. If you observe all of these, let me quickly erase these. If you observe these points here, you see that the relationship is falling along the straight line, a straight line, and a straight line. When the relationship falls along a straight line, the relationship is called as linear. However, if you see a relationship like this, Is it a straight line? No, it is not a straight line. It's a curve like that. It's called as curvilinear. Then that means it is non-linear. Okay, so you have all these linear examples and non-linear. So your scatter plot will help you understand the direction, strength, and whether the relationship is linear or non-linear. So we would now, what's the time? Yep, we are almost there. Just 4 more minutes left. So I will not get into the programming part now. We will do the programming part of this tomorrow, and tomorrow we will affirmatively build our first machine learning algorithm. Quickly, a recap. Project management methodology, CRISP DM. You first understand the business problem, then collect the data, then perform exploratory data analysis. As part of this, you perform first moment business decision, which is mean, median, mode. Second moment business decision, which is variance, standard deviation, and range. Then we discussed about graphical representation. We discussed about univariate plot, bar plot, histogram, and box plot. Then we moved to bivariate, wherein we discussed about scatter plot. Scatter plot will help you identify direction. Direction can be positive or negative, or there might be no correlation. Strength, strong, moderate, or weak, and whether the relationship is linear or non-linear. This is what we identify or we discussed today. And since we discussed these things, let me now quickly fill this. Okay, a few of you all were asking me for my LinkedIn profile. Once again, I posted here. Whoever wants to connect with me on my LinkedIn profile, please feel free to do so.